My name is Dewi. I'm Managing Director of Verocel Limited. There is a slight connection because in about 1990 I was one of the developers of the Spark Examiner, and the last time I downloaded the code, the open source code, I was pleased to see that the code that I wrote is still there and remarkably unchanged after 20 years. More recently, I've worked on a number of aircraft projects, including both the Airbus A380 and the Boeing 787. And for the past 6 years, I've been on SC205, which is the committee writing DO-178C, and I'm currently on the editorial team, which sounds very grand, but actually isn't. It just means that I'm one of the people who has to battle Microsoft Word to do the updates that everybody's voted on. It's taken us 6 years so far to write DO-178C, and I've got 25 minutes to tell you what we've been up to. So it's going to be a really lightning quick tour through DO-178C. And I'm going to focus mostly on the core document, DO-178C itself, because that's what I've been most involved with. So I'll start by recapping on DO-178B, for those of you who don't know. So DO-178B is the standard that pretty much all the software flying on airliners, like anything built by Airbus or by Boeing, has to meet. It was written in 1992, and it's a consensus-based document. So by that I mean that there were about 260 people on the committee that wrote DO-178B, and they came from certification authorities like the FAA and the CAA, from aircraft manufacturers like Boeing and Airbus, from equipment suppliers, and from software houses and consultancies. So it really is very much an industry document, and it does represent a consensus of the aviation community as it existed in 1992. The second main point about DO-178B is that it's an objective-based standard. So it's not process-based and it's not evidence-based. It's objective-based. And by that I mean that it doesn't prescribe any particular software process. It defines objectives that your software process has to satisfy. And you have to plan a software process that's going to comply with the objectives. DO-178B defines 5 software levels that go from level A, which is the most rigorous, to level E, which is software that has no safety effect at all. DO-178B emphasizes requirements-based testing. So you have to write tests that are based on the requirements and not on anything else, like looking at the code, for example. And it backs up the requirements-based testing with structural coverage analysis. So you have to test to make sure that all the requirements have been implemented correctly, and then you measure the structural coverage that you've achieved in order to make sure that you really have covered everything. And DO-178B infamously requires MCDC at level A. DO-178B also asks for bidirectional traceability. So you have to be able to trace from your requirements through your design down to the code to show that all the requirements have been implemented. And also you need to trace from your requirements to your test cases, test procedures, and test results in order to show that you've actually tested every requirement. And finally, DO-178B avoids making any quantitative claims for software failure rates. It simply says that it was the opinion of the people who wrote the standard that if you've got a software that can contribute to a catastrophic aircraft level failure condition, then you'd better meet the objectives that were set for level A. So DO-178B has been in service since 1992, and the record has been pretty good to date. There are just over 20,000 certified jet aeroplanes in service worldwide. There have been no hull loss accidents in passenger service that have been ascribed to software. I chose my words very carefully. I know, for example, that Airbus lost a flight test aircraft due to a software defect, but that was before the aircraft entered service, before it was certified. And software has also been a factor it's been a contributing factor in a number of aircraft accidents and has been responsible for a number of in-flight upsets. From what I can make out, we seem to be talking about tens of incidents rather than hundreds, and certainly not thousands. So actually, on the whole, I think that's a much better record than I would have predicted if somebody had asked me back in 1992, not that anyone did. So it kind of raises the question, is DO-178B doing a really good job, or have we just been plain lucky, or are we just not as dependent on software as we think that we are? And I think that would be a whole 30-minute talk in itself. So this is where we are today, that RTCA decided that it was time to bring DO-178B up to date to reflect the advances in software engineering that have occurred since 1992. And they create, in fact, DO-178B is actually a joint standard. It's published in the US as RTCA DO-178B. It's published in Europe as EUROK ED-12B. So they set up a joint RTCA Special Committee and EUROK working group. The current draft of the document lists 374 people who have attended at least one committee meeting. We've had 19 meetings between 2005 when we started in 2011. So we have about 2 or 3 meetings every year. And to give you an idea, each meeting has been attended on average by between 100 and 150 people. So as I said, DO-178B was published in 1992. In 2001, they published a second document called DO-248B, which provides clarification of DO-178B. It's a supporting document. And in 2002, there was a ground-based standard was added. So DO-278 is closely based on DO-178B, and it relates to ground-based and space-based, in fact, CNS ATM systems, air traffic control systems. As I said, in 2005, SC205 WG71 was formed and tasked with bringing DO-178B up to date. And I'll come back to this later, but we're due to deliver late this year. So what can you expect to see? You can expect to see a total of 7 new documents. So we're going to update DO-178B to DO-178C. We're going to update the ground-based equivalent, DO-278 to DO-278A. It's actually much better known in Europe as ED-109, so it's being updated to ED-109A. 248B is also going to be updated to 248C, and we're going to have 4 completely new documents. There's one document that's going to be about tool qualification, a second document, which is a formal method supplement. There's also a model-based supplement and an object-oriented supplement. So a key aspect of the terms of reference that we were given was that DO-178C had to be backward compatible with DO-178B. So that basically means that if your company's got a software process today that's compliant with DO-178B, then that software process should be compliant with 178C as well. And most of the changes that we've made to the core document has really been about clarifying areas where there were misunderstandings, where there were misinterpretations, rather than in creating any new requirements. So I'll start by looking at the changes to the core document. So one of the changes is that DO-178B used the words guidance and guidelines pretty much interchangeably. I mean, they both mean the same thing, good advice. But, and it's a big but, the word guidance has taken on a special meaning, especially in US federal regulation. So from the terms of reference we were given by RTCA, they define guidance to be material that can be recognized by the authorities as a means of compliance to the regulations, whereas guidelines are just supporting information. And so we started off by going through the document and trying to change the words, the use of the terms to be consistent with this definition. And we ended up with an early draft of the document that contained this, I'm not sure where the button is for this, but we ended up with this line at the bottom. We ended up with a wonderful sentence, guidelines don't contain guidance. And we thought, no one hasn't been on the committee is going to have any idea what the hell we're talking about. So we can't do this. So what we did was we've changed the document so we don't use the word guidelines at all, and we try to use the word guidance as little as we can, and where we do, we really do mean a possible means of compliance with the regulations. Another change, which is quite a significant change really in the core text, is that in DO-178B, it's an objective-based document, so it describes objectives that your software process has to satisfy. It also described activities and design considerations for achieving those objectives, and it also described the evidence that you have to provide to show that the objectives have been satisfied. And, I'm sorry?
You said guidelines here.
Guidelines? Yes, that's a mistake in the slide, yeah, sorry. Yeah, so this raised, actually, no, this is a quote from DO-178B. So in DO-178B, they said guidelines because guidelines meant the same as guidance. And I think this sentence in DO-178C now says guidance. Right, so the fact that we have objectives, activities, and and evidence raises the question that many people ask, well, what's the relationship between objectives and activities? Do we just have to do the objectives and we can ignore the activities, or do we have to do all the activities that are in the document? And there were two very different points of view, and I think they were both valid points of view. There was one group of people on the committee who said that if we don't make it clear that you have to perform all the activities, then people will just ignore the ones they don't like, and they'll just not do them and not provide any explanation as to why they left them out. And there was an opposite point of view, or a different point of view, that said, well, DO-178B is an objective-based document, so if we start putting too much emphasis on activities, then people will just adopt a checklist mentality, and they'll just blindly follow a prescribed set of activities without any thought as to why they're doing them. So what we ended up doing was to say that in DO-178C, we say that the document describes a set of activities for achieving the objectives, but you can substitute a different set of activities subject to approval by the certification authority, provided you can show that you meet the same objectives. Yeah, so I really need to speed up, I think. So we've made some changes. DO-178B has this idea of high-level and low-level requirements, and it's always been the case that you're allowed to merge you're allowed to have just the one level of requirements. And the original intent was that if you had a very, very simple software application, we didn't want to force you to create multiple levels of requirements where it didn't make sense to do so. But some people misused this paragraph to justify just creating one level of requirements, even for very complex applications. And there's a CAST paper, CAST 15, and I believe it's the only CAST paper that describes misuse. And so we've added a note to DO-178C, and the intent of the note is essentially to force you to go and read CAST 15. Derived requirements was another area that caused difficulty. There was actually an inconsistency in the document. So the glossary defined derived requirements to be additional requirements resulting from the software development processes, which may not be directly traceable to higher level requirements, whereas Section 5 of the text gave a different definition of derived requirements. It said that there are requirements that aren't directly traceable to high level requirements. And so we've fixed that in DO-178C. So we've said, well, even if you can, because our worry was that even if you can trace a requirement or high-level requirement, it may still be a derived requirement if it's really adding new behavior. We've clarified the section traceability to clarify that trace data is bidirectional, though trace data can be either explicit or implicit. We've clarified some of the objectives in DO-178B have to be satisfied with independence. So we've clarified what the independence requirements are. So we've updated the core text, and we've also expanded an existing FAQ in DO-248C, which I hope will make it a lot clearer what independence you need to satisfy. So DO-178B has always emphasized requirements-based testing. So we've made some small changes to the text to emphasize that. So for example, there there seemed to be a common misunderstanding that robustness testing was somehow to do with testing for behavior that wasn't covered by the requirements, and that wasn't the case, that we've emphasized robustness test cases still need to be requirements-based. It's possible that robustness testing may reveal incompleteness or gaps in the requirements, in which case you need to go and fix it. There's this objective called analysis of data coupling and control coupling, which is probably the least understood objective in DO-178B. So we've tried to, both in DO-178C and DO-248C, we've tried to explain what that objective means. And it's basically an objective that can only be satisfied by integration testing. So there are actually three objectives that relate to data coupling and control coupling. One is that you have to do reviews and analyses of your software architecture to show that data flow and control flow within your design is consistent. You need to do reviews and analyses of the source code to show that the control flow and data flow in the source code matches what you said you were going to do in the design. And finally, you need to do requirements-based testing, which is confirmed by this analysis of data coupling and control coupling to show that you've actually exercised all of the coupling in the code. We've got this thing which is called the hidden objective, which is this idea that if your software is at level A, then you need to, if you've got some object code which isn't directly traceable to source code statements, then you need to do some additional verification. So we've now made that a true objective, if you like, which is explicitly referenced. So we've added some guidance for deactivated code. And the final change to the core text is that we've got this new notion of parameter data items. So this is where you've got, you're now allowed to have data that you can verify and configure separately from the code itself. So if, for example, you've got tuning data for an engine control system, then provided you can show that the code works correctly with any valid tuning data, then you can change the tuning data without having to go back and retest the entire application. So as I said, DO-248B, we're also going to update to DO-248C at the same time. So we've expanded on two existing FAQs. One is to do with independence. The other one is to do with whether you can do structural coverage on the object code as well as on the source code. We've got some new FAQs and some new discussion papers. So there's a new one on MCDC, for example. And we've also added a rationale for all of the DO-178C objectives. DO-278A, that's the air traffic control standard. There was a proposal to merge DO-178C and DO-278A. They're going to stay as separate documents, but DO-278A is now going to be a standalone document. So if your interest is in CNS ATM systems, you don't need to buy DO-178C as well. You just need to read DO-278A. And it's very similar to DO-178C. The differences are that there are 6 assurance levels instead of 5 that go from AL1 to AL6. There's a lot more guidance in DO-278A on the use of COTS, and there's this notion of adaptation data, which is very similar to parameter data items, but is something that's is a big issue in air traffic control systems. So that moves me on to the new documents that we're writing. So there's a new document on tool qualification. So back in DO-178, so it's a standalone document. So if you're a tool vendor, you don't need to buy DO-178C as well. You just need to buy the tool qualification document. Back in DO-178B, we had 2 kinds of tools that could be qualified, software development tools and software verification tools. In the new document, we've got 5 tool qualification levels, TQL or TQLs. The idea is that they match. The criteria haven't changed very much, but it kind of makes a bit more sense now that you basically have a set of objectives for each of the different TQLs, and you figure out what TQL your tool is depending on the effect that it can have on the airborne software. Then we've got a model-based supplement. I think that model-based design holds a lot of promise to improve aviation safety. I think for one reason, potentially it offers a common language between systems and software engineers. It allows early animation of requirements, and it provides a shorter feedback loop between system processes and software processes. But it also raises a number of issues. So, for instance, when does a model express requirements, as in what the software has to do, and when does a model express design, as in how the software is supposed to do it? When's a model a system model, and when is it a software model? And how many levels of requirements and design do you need? One of the concerns that we had early on was that we didn't want someone to just build a model and then say, well, all my requirements are in the model and my design's in the model, and I'm going to press a button and generate the code and I'm going to be done. So the principles in the model-based supplement are that every model has to be verified against the requirements in which it was developed. We can use model simulation as part of the evidence to show that the model satisfies the requirements that it was developed from. There's been a huge discussion on how far model simulation can replace testing, and I think we're pretty close to reaching an agreement or consensus on that issue now. So we've got an object-oriented supplement. So we've got a panel session tomorrow on DO-178C and OO. So they had a very good starting point with the FAA OTIA handbook, and so we've now got a new supplement that addresses issues that are unique to object orientation. So it covers issues like how do you deal with inheritance, both single inheritance and multiple inheritance, how do you deal with polymorphism, and so on. And the final supplement is the formal methods supplement. So formal methods have a long history of use in the airborne software industry. I mean, I was personally involved in the early 1990s on program proof of a family of FADECs. The first one that we did was the FADEC for the Rolls-Royce RB211-535. And I read recently on Wikipedia that the RB211-535 is the most reliable jet engine ever built. So if it says it on Wikipedia, it must be true. More recently, Airbus have done a lot of really interesting work with a program-proof tool called the Caveat tool that's been used on the A380 and more recently on the A400M and now the A350. And the formal method supplement will now allow you to take credit for the use of formal methods such as Spark ADA, for example. So basically, you can use static analysis and program proof to reduce so you can do static analysis instead of review, and you can also reduce the amount of testing that you need to do by doing program proof instead. But you obviously still need to do some testing on the target. So this is our timetable to complete. So the last plenary that we had was in November 2010 in Long Beach, California, and 4 of the documents, DO-178C, DO-278A, the tool qual document, and formal methods, all went through what's called the final review and comment, or FRAC process, in December and January. And there's a UK equivalent called open consultation, I think OC. So what happens is that those 4 documents went to every RTCA member and EUROK member, and they had a month to respond with comments. So since the end of January, we've been addressing the FRAC comments in those documents. The plan had been to hold a plenary in Stockholm in April this year, but that got cancelled literally at the last minute. The plenary was supposed to start on Monday, and it got cancelled on Thursday because of the problems with the US federal budget. So on the Thursday, we were told that the US government was shutting down, and none of the FAA people would be allowed to attend. And actually, the RTCA rules say that you have to have a federal representative, otherwise the meeting doesn't count. So that got cancelled, and that really messed up our plan. So the plenary to replace the Stockholm plenary is now scheduled for the last week of August, so in a couple of months' time. In fact, since I submitted the slides a couple of weeks ago, it's now been confirmed as Toulouse. So we're going to have a plenary in Toulouse, and the plan is that following that plenary, we'll finalise the 4 documents that have been through FRAC, and the plan is then to send the 3 remaining documents, DO-248C, object-oriented and model-based, through the FRAC process. So, as I said, they go to all the RTC and EUROK members, they get a month to respond, which means that that means that basically September to the end of October will be the FRAC process. This is where things get very tight, I think. The current plan says that we have essentially 2 weeks to address the FRAC comments in those 2 documents, which I personally am not sure I believe. But if we do believe that plan, then it means that we're going to have a final plenary in mid-November. That's now been confirmed as Daytona Beach, Florida. And there's an RTCA PMC meeting scheduled for the 13th of December to give final approval to the document, and then it'll be rolled out, I guess, first thing next year. So that's it. I'm a little bit over, I'm afraid.